Good day, Sebastians. May the Sacred Heart of Jesus be loved everywhere. Welcome back. Please be reminded that we are in a new normal situation right now. Your focus, cooperation, independency, and honesty are really matter. Listen carefully and understand our new lesson. Good luck and have a blessed days ahead. It's good to see you again in our Lesson 2, Part 2. Still, we are dealing with arithmetic sequence and its application in real-life situation. We will be focusing in finding the formula of the nth term and the next terms of an arithmetic sequence. Let us recall first the definition of arithmetic sequence. We can say that a sequence is an arithmetic sequence if the consecutive terms have a common difference d. Let us go back with the example given to you in Lesson 1. The sequence 1, 4, 7, 10, 13, 16 is an arithmetic sequence, since their common difference is 3. Let us now find a formula for the general term or nth term of any arithmetic sequence. Let us denote the difference of two consecutive terms called common difference by d. If we say consecutive terms, there is a previous and next term. The following are some of the first few terms of the sequence. We can denote the first term as a sub 1. For the second term, we can obtain this by adding common difference d to the first term. For the third term, we can obtain by adding common difference d to the second term. But we can see that the second term is equal to first term plus d. So we can substitute this to the second term. So our final third term is first term plus 2 multiplied by common difference d. We can obtain the fourth term by adding common difference d to the third term. But we can see that third term is equal to first term plus 2 multiplied by common difference d. We can also substitute this to the third term. Finally, we have first term plus 3 multiplied by common difference d. Fifth term. As you can see, we can obtain fifth term by adding common difference d to the fourth term. But we can see also that the fourth term is equal to first term plus 3 multiplied by d. So we can substitute this to the fourth term. Simplifying, we get first term plus 4 multiplied by the common difference d. Based from the obtained formula of the previous terms, we can see that we always add first term to the product of the previous term number and common difference d. So the formula of nth term is first term plus n minus 1 multiplied by d common difference, where n is term number and d is common difference. Let us have an exercise on how to find the formula of nth term given a sequence. Given the sequence 11, 18, 25, 32, 39, what will be the formula of the nth term? We have to look for the pattern. Look for the common difference. So we can see the common difference is 7. So we have common difference 7. First term is 11. We can now use these two to find the formula of the nth term. By substituting the values of common difference d and first term to the formula, simplifying it using the distributive property and adding similar terms, our formula for the nth term is 4 plus 7 multiplied by n. Let us check if we get the correct formula. We need to substitute the first three terms of the sequence. We can see that we get the same terms in the sequence, so our formula is correct. Let us have another example on how to find the formula of nth term given a sequence. Given the sequence 9, 25, 41, 57, what will be the formula of the nth term? Again, let us look at for the pattern. Look for the common difference of the consecutive terms. We can see that the common difference is 16. Given the common difference 16 and the first term 9, we can get now the nth formula for the nth term. Again, we need to substitute the values of d and first term. Simplifying using the distributive property and adding similar terms. So our formula for the nth term is negative 7 plus 16 multiplied by n. Let us check again using the first three terms of the sequence. So we can see that we get the first three terms of the sequence, so our formula is correct. You can now answer Activity 5, Find Me Formula on your printed module. What if one or more terms are missing in an arithmetic sequence? How can we find them? Let us have examples. Given the sequence 9, 12, 15, find the 12th term of the sequence. Let us first identify what are the given. We have the first term 9, nth term 12, and we can see that the common difference is 3. Let us use the formula in finding the nth term to get the 12th term of the sequence. Substituting all the given values, simplify the equation. We have 42 as the 12th term of the sequence. Let us have another situation. The fourth term of an arithmetic sequence is 27. The 11th term is 69. Find the common difference, the first term, and the 25th term of the sequence. What we know? Fourth term is 27, 11th term is 69. What are we going to find? We need to find the common difference d, first term, and 25th term. Using the given data, 4th term and 11th term, we know that from the 4th to 11th term, there are 7 terms in between them. We can obtain the 11th term by adding common difference d to 27 7 times, or 11 minus 4 equals 7. This means that the 11th term is equal to the 4th term plus 7 multiplied by d. Using this formula, we have to substitute the given values. Simplifying it, so we have 6 as the common difference. So we have now the common difference 6. Now that we have already identified the common difference, we can now find the first term by subtracting the common difference 3 times from the fourth term to obtain the first term. So we have 27 minus 3 multiplied by 6 equals 9. Now that we have already identified the common difference, we can now find the first term, which is 9. Using the formula in finding the 25th term, we can now solve for the 25th term. Substituting the given values, simplifying the equation, we have now 153 as the 25th term. Therefore, to be able to solve the given situation, we need to find first the common difference, d, using the given data, 4th term and 11th term. After which, using the common difference, we can get the first term, which is 9. Having these two common difference, d, and first term, a sub 1, we can now use the formula in finding the 25th term, and finally, our 25th term is 153. Given the above examples in finding the nth term of a sequence, you can now answer activity 6 and activity 7. Use now what you have learned in the previous slides on how to find the next term of a sequence. Great job, Sebastians! You can now determine the formula of the nth term and can identify the missing terms in an arithmetic sequence. The next activity, we will be focusing on arithmetic series and means. Way to go! See you on the next video. Thank you for your cooperation and good luck in answering your activities.